Great. I'm Steve Kelly, President and CEO of Carisma Therapeutics. I'd like to spend the next 15 minutes telling you about what Carisma is doing and the direction we're going. The work we're doing is all focused around macrophages. I would argue that the macrophages are one of the most powerful cells in the body. They're found in every tissue. They're the only cell that's found in every tissue throughout the body. They are involved in tissue homeostasis, so pulling it back to the norm. They're the first responders of the immune system, identifying and eliminating things that shouldn't be there or should be eliminated. They also orchestrate the rest of the immune response. Our goal is to harness this power of the macrophage and direct it towards therapeutic applications like solid tumors and other devastating diseases. So Carisma was founded about 6 years ago. It's a Penn spin-out. The idea came out of the labs of Sar Gill and Mike Klaczynski. And as I said, they had this idea. How can we turn this powerful cell into a therapeutic? So we've spent the last 6 years building out our capabilities. We have a very robust platform at this point. We can do practically anything with the macrophage, directing it to go places and do things and change environments, what to kill, what to eliminate, and driving a T-cell response. We've been able to enable an autologous approach, which we're in the clinic with today. We have an allogeneic approach that we've done some work with the Blazer Lab at the University of Minnesota, and we partnered an in vivo approach with Moderna. So a lot of places we can take this platform. Our first application is solid tumors. We have a HER2 program in the clinic today. We have a mesothelin program that is coming along behind it. We'll have a development candidate identified very shortly. We have an in vivo platform with Moderna, partnered with Moderna, where we have 5 targets that have been nominated so far that will lead to we hope to be presenting some data on a preclinical proof of concept on the overall approach at a scientific meeting coming up very shortly. And we hope to have a development candidate nominated early next year as well. Lastly, we think that we can deploy macrophages to non-oncology applications like liver fibrosis. It's an area that is growing for us as our third leg of the stool. Ex vivo oncology, in vivo oncology, and non-oncology. I think important for us as we set out to build the company is to have a regular cadence of value inflection points. So we have clinical data that reads out approximately every 6 months or so, and we continue to see that for the foreseeable future. We have preclinical readouts on both the platform and the pipeline as we go forward as well. And then finally, we're funded beyond those catalysts. I think it's important to make sure that we can deliver everything that we've stated that we're going to do, and we're sort of funded through the end of next year. Now, I said our first application is solid tumors. And, obviously, CAR T is enormously successful in heme malignancies, a little bit challenged in solid tumors. And we think it comes down to 3 basic areas. One is the ability to access solid tumors. There are both physical barriers for them, and then there's immunologic barriers or immunosuppressive barriers for application as well. And then finally, there are issues of antigen heterogeneity. Unlike CD19 CAR T, we're looking at 99.9% of B cells express CD19. That's not going to be the case in solid tumors, so you run a high risk of antigen-negative relapse. Macrophages are ideally suited to confront each of these 3 challenges. Number 1, they're preferentially recruited to a tumor. You'll find it's the most common immune cell in a tumor microenvironment, and we're going to leverage that natural ability to get there. Once our cells arrive, they'll engage antigen on the cell surface of the tumor cell, and that will trigger phagocytosis through our CAR. And so they'll start to eat. So a direct killing mechanism initially. As they're eating, they'll be producing a variety of pro-inflammatory cytokines and chemokines that warm the TME and recruit in other effector cells. So we see an influx of T cells, NK cells, dendritic cells. And so we're going to just take an immunologically cold environment to a warm or hot environment. Lastly, and importantly, macrophages are antigen-presenting cells. And so as they're eating through the tumor, they'll process and present various secondary antigens out through MHC, a concept known as epitope spread. So we'll have broad immune memory against not just our primary antigen, but other unique antigens for that patient's tumor. And so each of these concepts, the ability to kill, the ability to traffic, the ability to kill directly, the ability to remodel the tumor microenvironment, and a generation of a broad adaptive immune response are all been demonstrated studied preclinically, and so we moved into the clinic. Our pipeline chart is shown here. Our lead program, CT-0508, has been in the clinic. We presented data on the first 14 patients treated so far. Two ways we did it. One is fractionated dosing, and then secondly is bolus dosing, and I'll talk a little bit about that as we go forward. One of the strategies that we have from that data, that emerged from that data, is to combine with a T-cell checkpoint inhibitor. And so I'll show you the plan on that as well. The other strategy we have is related to increasing the cell number. Now, macrophages are terminally differentiated cells, so you don't have an expansion phase during the manufacturing process. And so what you're able to harvest and make is what you're able to administer. So our approach is to make CAR monocytes. CAR monocytes are a shorter process that enables us to make nearly 5 times the number of cells in a single-day process. So we're planning on filing an IND on our CT-0525, another HER2-targeted program. As I said, we have 1119 as our mesothelin program. We have some work going on in liver fibrosis and other non-oncology applications, and we have 5 programs partnered with Moderna. But on 0508, so it's our HER2-targeted CAR macrophage. Like I said, we've been in the clinic as a single agent for a while. Fractionated dosing is what we looked at first as a safety read. First time an engineered macrophage had ever been administered to a patient. And as I'll show you, that's a very clean safety profile. Then we moved to bolus administration, so all the cells that we can make on a single day. On average is around 2 billion cells. And so we've treated 5 patients on our bolus administration. And then lastly, we have our Pembro combination study that is ongoing, and I'll talk to that in just a moment as well. Now, the aims of the study were feasibility, and so I'm happy to say that we're able to reproducibly make CAR macrophages from donor patients, high CAR expression, high purity, high cell viability. We are able to make M1 polarized cells, a pro-inflammatory phenotype, and this is all the manufacturing runs to date. And then lastly, they're functional, so we do 2 killing assays. And so reproducible, again, we can make around 2 billion cells on average. The second question was around safety. Can we safely administer these activated macrophages, if you will, to patients with a good safety profile at the numbers we're administering? Again, it's 2 to 4 times higher than a CAR T dose. And we can. So group 1 was a fractionated dosing, group 2 was bolus dosing, and then the combined. What you see is a clean safety profile. The most common adverse event is CRS, grade 2 CRS that was transient and went back to normal within about 48 hours. No major organ system toxicity, no ICANS. It was just a good safety profile that gives us confidence when we move into the higher doses with the monocytes. The next thing we looked at, of course, is response. We saw stable disease, so not ideal, but I'll talk about what we learned here. The couple of things we saw. One, we saw tumor shrinkage. So we are seeing some anti-tumor activity with lesions shrinking by up to 20%. There are some, of course, growing through and some not. But we think that showing some anti-tumor activity was important. We started to look at a little bit more. So are there any indicators on what patients would respond or have a better outcome than others? And one of the things we looked at was HER2 antigen density. And so 2+ patients, you can see the pie chart on the far left, is we saw no stable disease patients. With the 3+ patients, we saw 4 out of the 9 patients were stable disease. So that was interesting for us to see. Too early to say that we want to have high antigen density patients, but I think that it shows that we are able to get a better outcome in a higher antigen density. On the right-hand side, you see that these are HER2-positive tumor cells declining. So the take-home here is that this is an antigen-dependent outcome, clinical outcome, and we think that this also supports the idea of increasing the dose. So getting more cells in to go after more antigen would be beneficial. The next thing we looked at is in terms of the remodeling of the tumor microenvironment. Not on this slide, but we did see that there's a recruitment and activation or recruitment of M1 bone marrow-derived macrophages that change the environment. You see a significant higher number of pro-inflammatory cytokines in the tumor microenvironment. But we also looked at what was happening across the board with some gene signatures, and specifically looking at what's happening in T cells. And so we saw an increase in the gene signature for antigen presentation machinery in the better outcome patients. We saw a tumor inflammation signature that Merck uses for pembro responsiveness higher in those patients. We saw immune cell recruitment and activation higher in those patients. The other thing we saw is on T cell clones were expanding in a more robust expansion in T cell clones for the stable disease patients versus the progressors. And then lastly, we saw a much higher level of emergent T cell clones. These would be the neoantigens we expect from that patient's tumor. And so these are all things that were pretty interesting, suggesting that a more robust immune response is coming from the T cell compartment. The last thing I would look at, and I know we have tight on time, but two things I would call your attention to. One is looking at a healthier immune system appeared to have a better outcome, so looking at CD4-CD8 ratio. And then lastly, I would point out there's an exhausted T cell phenotype emerging. Some not surprising given these patients have been treated 5, 6, 7, up to 11 lines of prior therapy. So those are the two take-homes on this slide. So where do we go from here? I think we've shown feasibility, we've shown safety, we've shown mechanism of action, we've shown stable disease, we want to achieve clinical benefit. There are two places that I'm going to highlight on this slide that we think will lead to that. Number one is a combination of CAR macrophages plus PD-1, or PD-1 blockade. And so I'll show you some data on that on the next slide. The second thing is increasing the dose, and we'll do that through CAR monocytes. So on PD-1, this study is ongoing. It's a combination study with pembrolizumab, and it's a couple of cohorts where we're looking at combining CAR-M plus pembro, first in a delayed fashion, and then simultaneous with fractionated dosing, and then simultaneous with bolus dosing. The thing I call your attention to here on this slide is some preclinical data that suggests there's synergy between the two. So if you look, this is a pembro-resistant model where we're treating with CAR macrophages, anti-PD-1, and then the combination. And then, so CAR macrophages around 35% durable response. CAR macrophages plus pembro, you're seeing around a 65% durable response. But I think the more interesting thing is what's happening in the tumor microenvironment. So in the blue box there, that blue is tumor, and the control, nothing really changes. When you treat with anti-PD-1, you see an influx of macrophages, but no T cells. When you treat with CAR macrophages, you see both macrophages and T cells coming into the tumor. And when you combine the two, you see this profound change where you have elimination of the tumor and more robust immune response, including pockets of dendritic cells and things like that. I'm going to go back one. Sorry. So I guess the take home, what we think is happening here is that with CAR macrophages, you're able to recruit and activate T cells, but they're an exhausted T cell phenotype. With pembro, you can disexhaust T cells, but they're still confronted with the same challenges of getting into the tumor. When you combine the two, you're recruiting and activating and disexhausting T cells, and you have a profound outcome. So we're really excited about that study, and like I said, it's up and running now. The next thing that we're doing is our CAR monocyte. Our CAR monocyte process is very similar to our CAR macrophage process, but rather than differentiating monocytes ex vivo into macrophages over a 5-day process, we transduce the monocytes directly, and we cryopreserve. In this way, we're able to make 5 times the number of cells, on average around 10 billion cells from that process. And there's a number of biologic advantages we believe in including better trafficking, better persistence, better cytokine production, et cetera. So we're pretty excited about this, and as I said, we'll file an IND and get that allowed this year and get into the clinic early next year. So just to wrap up in the last 56 seconds, as we look forward, what are the outcomes that we're looking for? There are 3 buckets. 1, clinical activity. We're going to be presenting the anti-PD-1 combination data. We'll have data at the end of this year, and we're looking for a forum to present that. We will be filing an IND and having that allowed in the 4th quarter. That will lead to a phase 1 initiation with data coming as a single agent early in the second half of next year. year, and then we'll move to a combination approach. We are progressing our next generation CAR designs into our mesothelin program, and we're moving forward with our in vivo approach that we'll be presenting the proof of concept very shortly as well. So, and then the last thing, I got 9 seconds, we have some liver fibrosis data that we'll be presenting next year as well. So these are all the things that we're working on, and thank you for your time and attention.